All right, hey everybody, this is Mr. MathWell here, and we're going to talk about net diagrams, okay? Net diagrams. Now, if we have a three-dimensional figure like this, and this is a rectangular prism, it's got a rectangle for a top and the same rectangle for the bottom, and on the sides we have different rectangles, right? And on the ends we have yet another type of rectangle. So this is a prism. And a net diagram is basically a two-dimensional drawing of all of the sides of a three-dimensional figure, and they're all connected. So this is what we're going to do. We're going to basically start to trace out, okay, trace out the sides for this three-dimensional figure. Now what I'm doing is I'm tracing the bottom side, okay? So here is the rectangle, that's the bottom. In a net diagram, on the same paper, we want to draw all the sides. So what I'm going to do is I'm just going to flip this over, and I'm going to trace this other side. Okay, so this is a different rectangle, but this represents this side here. You see that? Got the base, got the side, and what we're building is a net diagram. I'm going to flip it over one more time, and guess what? Now I'm going to trace out the top, and this is what the top looks like. Okay, so when you're doing net diagrams here, the reason why we draw net diagrams, one of the reasons, is so that we can find the surface area. So to find the surface area, you're basically finding the area of all of the sides of a three-dimensional figure. And when we have it laid out like this, you can actually see that, hey, the top and the bottom are identical. This other side is going to be like this, and you can keep track of all of the areas that you're trying to measure, and you can add them all up when you find each individual one. You can add them all up. All right, so I've got, let's see, I've got bottom, I've got side, I've got top. These two ends are the last ones we're going to do, and I'm just going to, for sake of time, it's going to be a short video. I'm going to swap this one out. The rest are in pencil. I apologize, they're a little bit dull, but here we go. I have a net, a finished. Oh, that one's not even the better one. This is a better one. Okay, so this is a net diagram for this same thing right here. Okay, so bottom, side, top, other side, and now the ends, you see, got to trace the ends there and there. And so because we have 1, 2, 3, 4, 5, 6 sides here, I'm going to have 1, 2, 3, 4, 5, 6 sides represented on my net diagram. So this is a net diagram for this guy right here. What about some other shapes? Well, let's quickly go through those. Okay, so what about this one? Right? Oh, where is it? This one right here. Okay, that guy right there. That is a triangular prism. We have a triangle on the end, identical triangle on the other end, and then it's just there's a height there. There's a depth to it. So this is a triangular prism. Now, if we traced all the sides here, flipped it over, trace, flip it over, trace, just copy, trace each side once, we're going to get a diagram that looks just like this. Bottom, side, side, end, end. So there's 1, 2, 3, 4, 5 sides to this one. Side, 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 end, end. Okay? And that's your net for your triangular prism. All right, moving on, let's get a few more in here. What about a square-based prism? Okay? Sorry, this is a square-based pyramid, sorry. A square-based pyramid. So we have a square, and then the pyramid, all the sides, all the corners kind of meet up at the top, at one point above it. So that's what a pyramid is. And this is a square base because we have a square base. So if we started tracing all these sides, flip over, trace, we get something that looks like this right here. There's the base, there's one side, okay, there's another side, there's another side, and another side. So that's what the net diagram looks like for a square-based prism. A square on the bottom, and 4 triangles extending off of each edge of the base. Okay? Alright, moving along. This is a rectangular-based prism, the one that looks like just like that. See, the base is not a square, now it's a rectangle, and then all the corners meet up to the middle. And then you flip this over and trace, flip this over and trace, and so on, and that's your net diagram for the pyramid. Okay, so let's get into something a little more tricky like this one. Okay, so that's a cylinder. Well, what are we going to do with a cylinder? Well, we know that we have two circular ends, right? There's an end there and an end there. So we're going to have two circles, one over there, maybe one over here. And then the wraparound part is tricky. So this is what I did. Okay? In order to find to draw a two-dimensional representation of the wraparound part, what I did was I put a little mark there, and I put a little mark on the paper right here, and identical on the other side. And then what I did was I kind of rolled it along like I'm kind of like there's paint on there and I'm painting a surface, and I rolled it all the way around till it got to the exact same spot. Made another mark there, another mark on the other side, and then when you connect these points there and there, and then of course close off the ends, you see that the wraparound part is actually just a big rectangle. Yeah, it's a big rectangle. And so it doesn't have to be too tricky. We got a circle here, you know, I'll do this real quick, circle there, and then a circle anywhere on the other side as well. And you trace that around, and there is your net diagram for the cylinder. Here's one that's a little bit neater, okay? And that's exactly it. So the other important thing to notice is that this length of this rectangle that makes the wraparound part is the length here is the same as the distance around the circle, see? Because it's wrapped around and it touches the circle all the way around. And this is called the circumference of the circle. The circumference is C equals 2 times pi times r the radius of the circle. Okay? So that's C equals 2 pi r. Of course, this would just be your height, whatever that is. The height of the cylinder. Okay? So that's a net for the cylinder. Awesome. I got one more. Okay? And this one involves a circle too. This is a cone. Not as interesting as an ice cream cone, because there's no ice cream on the top, of course. But this is the shape of a cone. It has a circular base, and it's a pyramid style, right? There's no sides, though, because there's no sides on a circle. Or you could say there's an infinite number of sides, but we won't get into that. But a cone is just like a pyramid, except it has a different shape base. Okay? Cone, pyramid. A cone has a square base. So this is easy. This part is easy. You know, just trace the circle, and there you have your end. Okay. Now you might think that this wraparound part is a triangle. Besides, there's a bottom, there's a side, and there's a side, right? Except, this is how I'm going to show you this, okay? I've made a mark here on the bottom of my cone. I'm going to make a mark at the tip of the cone over here, see, tip of the cone. And actually, you just see what I just did there. Okay, in order to map this wraparound part, I'm going to let it roll. Look at that. I'm going to let it roll. I'm going to let it roll exactly halfway around. I'm going to make a mark. I'm going to roll it back to the center. Boom. And I'm going to roll it around halfway again with it pivoting on this point exactly. I'm going to make a mark. And if I follow my pencil around, this is going to be a little tricky to do properly, but if I roll it back like that, look what happens. Look at how that's a curved surface. And the cone actually, the net for the cone looks like this. It's exactly what it looks like. This is this cone right here. Okay, circle, radius r, and then we have this. Look at that. Okay, that's how you map that part. So this is it's like a lamp. It's like a lamp net. It's like a lamp. Let's turn the lamp on. This is S, the slant height. So look on your cone. If this were a triangle, this would be the slant height, not the overall height up the middle, but the slant height. So this is the slant height. Okay? And area for cones and stuff, we'll talk about that in another lesson. But that's your lesson on net diagrams for your different shapes there. Hope that helps.